Hello, geometry students. In this lesson, continuing to analyze quadrilaterals, and this time I'm going to use midpoint. Find the midpoint of each diagonal. Go ahead and graph this over 1 up 2. Have to do it in blue, of course. 2, 5. 5, 7. 4, 4. On the face of it, it looks like a parallelogram. I'm going to determine if it is a parallelogram by looking at the midpoints of the diagonals. For a parallelogram, the midpoints will actually bisect each other. So I'm going to start by finding the midpoint of BD. Now you can use the formula if you want. Well, I take that back. You must use the formula. The formula is add your x's, divide by 2, add your y's, divide by 2. So it doesn't matter which one is x sub 1, x sub 2, you're adding them together. So for this BD, I'm going to add my x's. I'm looking at 2 and 4. 2 plus 4 over 2. And then when I add my y's, it's 5 plus 4. 3 comma 4.5. Now let's find the one for the blue one. Do the same thing. I'm going to write it as a coordinate pair. I'm going to go with AC. So I'm looking for the x's. That's 1 plus 5. And then 2 and 7. That's also 3 comma 4.5.
Students, for the interruption, we need our Dungeons and Discourse group to report to Ms. Marsh Pierce or Mr. Carr's room. You should not be in any other location. Please report to Ms. Marsh Pierce or Mr. Carr's room. Thank you.
So my conclusion, I write it the same way every time. ABCD is a parallelogram because and the reason is because the diagonals bisect each other. Diagonals which they will on a parallelogram. Determine the shape of this one. I'm going to start by graphing it side to side 0 up 1, that's M, over 2 up 6, over 7 up 4, and then 5 negative 1 is going to be off my grid. On the face of it, it looks like it's a square. But I don't know that for sure until I prove it. You can't just say something's a square without proving it. So I'm going to try and find the midpoint. On this one, I'm only looking at the diagonals. So I'm going to start by looking at the purple diagonal, which is NR. For NR, I need the midpoint and I need the slope. So I'm going to start with the midpoint. Again, you can actually, I must use the formula for this. I'm looking at x's. That's 2 plus 5, which is 7 over 2. And I'm looking at the y's, 6 and negative 1, which of course is 5 over 2. That's about what I expected, is 3.5, 2.5. Now the slope of NR. I'm going to use a slope triangle. I'm going to go down and over. So down 1, 2, 3, 4, 5, 6, 7, and over 3. It's a negative 7 over 3. Now go back and do the same thing for the other diagonal, which is called MP. I'm looking at MP, so it's 0 and 7 divided by 2. Of course, that's 7 over 2. And then 1 and 4 is 5. So they have the same midpoint. That means their midpoints are bisectors of each other. That means this is at least a parallelogram. And so for the slope of this one, again, I'm going to do a slope triangle. It's going to get a little confusing, but up 3 over 7. It has a rise of 3 and a run of 7. That's 3 over 7. And as you can see, these are perpendicular. So my conclusion is this really is a square. And the conclusion is MNPR is indeed a square because and the reason is the diagonals are perpendicular bisectors. That's all that's required for a square. Diagonals perpendicular bisectors. If you had something else, like for example, if they were perpendicular but not bisectors, you might have a kite. If you had things that were bisectors but not perpendicular, that could be a rhombus. All right, well, look at the next one. May be wrong about that. Determine whether this is a rhombus or a square or neither. So start by graphing -3, -4. Excuse me. And 2, -2. On the face of it, this looks like it could be a rhombus, but I don't believe it is. It looks like it's a parallelogram, and I am going to, as usual, analyze using just the diagonals. Whoops. It's asking for the midpoint first. I'm assuming that I'll do something else on the next page. So for the purple one, it actually looks like it's going to be 0, 0. But I'm looking for, I forgot to label it, I'm looking for BD. I'm looking at this and this. -2 plus 2 divided by 2. Of course, that equals 0. And then for the other one, it's 2 and -2 again, which of course is also 0. The midpoint for the other one, which is called AC, is probably going to be the same thing, but you can't say that for sure until you actually prove it. That's the whole idea of proving quadrilaterals, is to give me the evidence. In fact, it is 0, 0. So these are bisectors of each other. But then the question is, are they perpendicular? I can't say until I check for sure. Excuse me. So again, I've got the purple one, and I've got the blue one, and I need the slopes. So the slope of BD is equal to, it looks like it's down 4 over 4, also known as -1. AC is a little, so I'm going to go up and over. I believe this is 8 and this is 6. So that slope is a +8. They are not perpendicular. So my conclusion, ABCD, the only thing I can say about it is that it is a parallelogram. And the only reason is that because the diagonals bisect each other. It's not a rhombus because they would have to be perpendicular. It's not a square because they would have to be perpendicular also. So this is not a square. This is just a parallelogram because diagonals are bisectors. And that's that.